Okay, so I have 4 cookies, and every cookie has 3 chocolate chips inside of it. Okay, so I'm going to ask you some questions about the story problem. How many cookies do I have? Elise?
3.
I have 4 cookies. There's 4 cookies, and each cookie has how many chocolate chips, Emily?
3.
Right, okay, 4 cookies. Each cookie has 3 chocolate chips. So, Andrew, does each cookie have the exact same number of chocolate chips?
Yes.
Yes, they do, right? They each have 3. So, Peter, if I know how many cookies I have and how many chocolate chips each cookie has, can I find out how many chocolate chips there are in all?
Yes.
Yes? Okay, so right now I want you to solve this problem by yourselves individually on your whiteboards, and you can use any method that you want to solve this problem. And go ahead. Show all of your work. Any method that you want. We have 4 cookies, and each cookie has 3 chocolate chips. How many chocolate chips do I have in all?
I'm so tiny. It is.
Just do your best.
I just put CHOLATE.
All right. Okay, looks like everybody's done. Don't erase yet. Put your dry erase pens down on the table, please. Emily, can you explain to me and your classmates how you solved this problem? What did you do?
I drew 4 cookies and 3 chocolate chips in each one, and I counted them all together, and I found 12.
12. Okay. What did you do to solve this problem, Andrew?
I counted.
You counted them? How did you count them?
By 3s.
By 3s. Can you demonstrate counting for 3s for me?
3, 6, 9, 12.
3, 6, 9, 12. Wow, that is a great strategy. What do you guys think about that strategy? I think that's a pretty good strategy to figure out how many chocolate chips there are in all. Yeah, that's a pretty good strategy. Peter, what did you do?
3 times 4.
3 times 4, and you knew that that was 12. Right, so what type of problem was this then?
Multiplication.
Right, this was a multiplication problem. Very good. Okay, what did you do, Elise?
First, I counted the dots.
So you drew a picture?
3 plus 9.
And then you counted them? And how many chocolate chips did you find there were in
12,
all?
because I didn't count them, but since it was easy, I did I just counted this 3, and then he ends with it.
You counted by 3s as well, so 3, 6, 9, 12. Okay, so those are some great strategies that you guys used in order to solve this cookie problem. So I have a question. What is the fastest way to count groups of things? What's the fastest way? If I have a lot of things, how could I figure out how many there are in the fastest, most efficient way possible? Emily?
Counting them in groups.
Counting by groups. Good. Okay. And that's what some of you did here. Some of you, like Andrew and Elise, both of you used counting methods where you said, okay, there's 4 cookies and each cookie has 3 chocolate chips, and you counted up by 3s. So that's like saying 3 plus 3 plus 3 plus 3 equals 12, right? You could also write this as a multiplication problem. And that, right, so 3 times 4. And that's what Peter was talking about, right? When he told us about how he solved a problem. So I want to talk about now what the difference is between multiplication, which uses this symbol here, and addition. So if I were to make an addition problem using the same numbers, how would I write that? Emily?
3 plus 4 equals.
3 plus 4 equals, and what does that equal, Andrew?
3 plus 4? 9.
9. Are you sure?
6. 6. Wait.
Double check your mental math right now. I know you guys know this. Elise?
Oh, 7. Oh.
We don't have to borrow. We have 3 plus 4.
Oh, 7.
7.
I was confused.
It's okay.
So close.
It's okay. So look at these 2 equations that I have written up here on the board. Who can tell me one thing that they notice that is different?
Oops.
Do you notice something different, Peter?
No.
No? You don't notice? What's different about them?
It's 7. The 7 is less than 12.
7 is less than 12. Good. Okay, that is a really good observation he made here. Do you have another observation?
Yeah. If you do times tables for 3 and 4, they add a bigger number.
Yeah, so
Then
this
the
number
other
is a
number.
lot bigger than this number, right? That is another great observation.
Because the 3 is repeating itself 4 times.
That is exactly where I was going to go with this. Thank you so much, Peter. So when I'm adding 3 plus 4, which gives me 7, right? It's not the same as adding 3 4 times, right? Up here we have 4 3s, and that equals
Because
12.
if you put 3 plus 4, it's only repeating itself 1 time.
Exactly. And it's not even repeating itself, really, right? You have a
Only
3
once.
and a 4, and it's just 1 3 and 1 4. Good. So those are really good differences between multiplication and addition. Go ahead and erase your boards. I'm going to give you a new problem.
Look how easy things.
Here you go.
That would take a long time. Just my head doesn't even. Oh, it's gonna be so sticky. See, it doesn't even get dirty.
All right.
Yes, it does.
So I'm going to give you, what if I changed, I still have cookies, but I have a different amount of cookies. What if I change the amount
Like 7.
around? No. So now I have 3 cookies, right? Last time I had 4 cookies. Now I have 3. And last time each cookie had how many chocolate chips?
3.
It had 3. So this time, what if each cookie had 4 chocolate chips? 3 cookies with 4 chocolate chips. How many cookies do I have? 3, right?
Oh, just 1, 2. Think if I get that too? What do you say? You write it like that too? You write left finger? No, I mean write like that.
Go ahead and stay focused on your problem. Figure this answer out, please.
It's the same amount of chocolate chips. It's really easy. It's the same. Because it's turning around.
So I hear a couple of you guys making very great observations that even though we have a different number of cookies and a different number of chocolate chips, we've got the same number. We got the same answer, right?
Yeah, because we used to have 4 and 3. Now that you added 1 more to it, it adds to 12.
Yeah, so I like the number sentence that you have over on your whiteboard. Can you come up here and write that number sentence next to this number sentence for me, please? Okay, you can use a marker, that's fine. Just right here next to it.
I know why it's the same.
1 second. Great, thank you. Okay, so Peter says he knows why it's the same. Can you explain it to the rest of us?
Because if you just have 3 times 4, but then you switch it around, it's still the same. It's a turnaround.
So what I hear you're saying is it doesn't matter what order these 2 numbers are in, right? It doesn't matter the order, it'll always equal 12, right? Yes, Andrew?
Before they have another circle, but we erased it and put 3. That's why we have.
number of chocolate chips, which is what the question asks, how many chocolate chips, even though the number of cookies changed, did we still get the same answer, Andrew?
Yeah.
Yeah, we did. Great. Okay.